This is chapter 4, number 20. What it tells us is we're on some store window and we throw something down, and it tells us the initial velocity we throw it is 8 meters per second. We throw it down at 20 degrees, and we know that it takes 3 seconds to hit the ground. Now we're going to use this information to figure out, well, let's first figure out how high the window is. So let's look at our position equation. And again, we're looking only in the vertical sense. And so how high is the window if it hits the ground? Again, we don't know the height of the window, but we're going to throw it down at 8. Again, we're throwing it down, so it's going to be a minus sign there. Sine 20, 3 seconds, and again we're in free fall for 3 seconds. And so when you solve that, you get an h of 52.3 meters. Okay, let's figure how far it goes. Well, that's actually pretty easy because we know that x equals v naught cosine theta times t. Remember, v naught cosine theta represents the horizontal velocity. So how far does it go if we threw it at 8 meters per second times cosine 20 times that 3 seconds? We could have done that right away, 22.6 meters. And then I believe it says, how long does it take the ball to reach a point 10 meters below the level of launching? And so we have the first two answers, and now we need to figure out 10 meters below. Well, 10 meters below would really just be 12.6 equals 22.6. Again, minus 8 sine 20 t minus 1/2 gt squared. Again, this is just the standard position equation, which is right here. I want to go 10 meters down, so just subtract 10. This is minus, we threw it down at 20 degrees. How long is it going to take? And again, this is a quadratic. I would graph this as y1, this side is y2, and when you solve that, you get a time of 1.18 seconds. So now we know how high the window was, where it landed, we knew everything else at the beginning, and then this particular sidebar question told us how long it took to drop 10 meters.